So a couple of years ago, I was playing around trying to learn how to use shaders, how to program shaders, etc. And one of the things that you can do just while learning is creating the Mandelbrot set as a shader. Um, and I ended up making something like this. I wanted to make it more interesting and all that, and I ended up making a Mandelbrot bouquet, as I called it. It's essentially just a bunch of layered Mandelbrot sets, one on top of the other, rotated, stuff like that, mirrored together, and with different coloring, basically. But I wanted to visit the Mandelbrot set, maybe make a simpler version of it. The idea is one that works on the terminal, and you can just explore it in the terminal. We can obviously use the same process that we did in here, but one of the first things that we should probably discuss is, well, what exactly is the Mandelbrot set? And I'm not a mathematician. I don't have a formal definition of it, but it's essentially the set of numbers that when you do some mathematical operations to them, you square them and then add them, stuff like that. Add the value to itself, etc. It either converges to 0 or to a very small value, or it just blows up to infinity, right? The numbers that don't blow up to infinity are the ones that create this fractal pattern, etc. Right? And in here I'll basically create a terminal explorer of it, and you can see the result, the final result, right here. I'm gonna just put it in the video first, and then we'll go through this code and what I did basically in it. So in here I have a very straightforward, terminal and all that, and we can basically run whatever we want in here. And to start with, I have a couple of constants and values that I would want to use in my code. These constants are the maximum iteration, stuff like that. And I'll explain what each one is doing. So these are the basic ones. We have a gradient, and that's going to be essentially the gradient value of what we're going to print. So a very bright value will be an at sign, an at character, and a very dark value will essentially be nothing. We use the maximum iteration, obviously, in the informal discussion that I use right now. The idea is that if you go to infinity, if you square and add and square and add and square and add, but we can't do that obviously with computers, so we just put some value. If it reaches 1,000 and it still hasn't blown up to infinity, then probably this number is this value is inside the Mandelbrot set. I use a character aspect ratio. Basically, if you think of every character as a pixel, you can see in here the character isn't like a block 1-to-1, right? It's actually more than that. I'm not sure. I didn't try to measure it exactly. I'm just putting 0.5 as a number. You can probably experiment with other ones, 0.35. It's things like that. It might be like 16, but I'm not sure. But it looks like double it basically. So that's what I'm using. I want to be able to move around, and so we're going to be keeping track of a zoom value and which center are we at, right? So when you move left and right, you can know where exactly that is. And because we're going to use the arrow keys and some other keys for zooming and moving around, we need to have like a pan speed and a zoom factor that we need to keep track of. Or, that they need to be constant, that will be used when we're moving around. And the second thing is we need a complex class. This class is pretty straightforward. I didn't try to make it more complicated, but it basically has a real and an imaginary part. The constructor basically does that, right? Has a magnitude. We'll be using this magnitude inside of our loop. You don't need to use the squared magnitude. You don't even need to do the multiplication of them. If I'm not mistaken, even my shader, I'm not even using, I'm not even multiplying them, and it can make a good result. It doesn't really matter, really. At the end of the day, whether you're multiplying or whatnot, it'll either reach infinity or not, right? So we don't need to necessarily make this, but in this case, I just to keep it a bit consistent, I use multiplication. It's the same one that they have, I think, in here. Yeah, they're using the squared values of them, and that's essentially what I'm doing in here. And so now we have everything set to actually define the Mandelbrot function. And I have it right here. Let me just add it to our code. And yeah, let me go through line by line, explain what is happening, and then, be able to actually run it and see the final result. So we have an iteration number, so that's how many iterations that we're going through. We define the complex value that we're going to start with, 0, 0 at the beginning. And essentially, if the magnitude is less than 4, it can be other numbers. It doesn't need to be 4. It's just some value that bounds it, right? And we haven't gone through the maximum iterations, so we haven't blown up to infinity, right? We essentially square the number and then add the x and y value. In this case, the x and y value will be the pixels that we're going to use, right? So 0, 0 would be, the center, 0, 1, etc. These are the actual points of the complex plane. And we will use the number of iterations. So if we reach the number of iterations, and we're very close to it, essentially, then most likely, this number is pretty close to the Mandelbrot set. So we'll give it some color. But if it just blew up very, very quickly, it never reached anything close to the maximum iterations, most likely that it's not, right? That's the basic idea that we're going to have. So now we have everything. We can define a render function. And this render function is pretty straightforward. We have a width and height. That's essentially the width and height of the screen of the terminal here, right? We can use standard output with the columns and standard output with the rows. I'm doing -2 in here because we're going to have some line for the input and another line for just a simple prompt to tell the user how to, use our Explorer. And just in this case, the AI added these stuff. I'm not sure if it's necessary. Maybe there might be some terminals that this won't work at. So in that case, we'll use 80 and 24. You can use any other value if you want to. And the aspect ratio is obviously the width and the height multiplied by the character aspect ratio that we defined at the very top in here, right? Which again, you can play around. You can use different values if you want to experiment with it. And yeah, so the first thing is we're going to clear the console. So every time, this is essentially running every time you change something in the data. So you do a character, you move or pan around, zoom in, zoom out, etc. Right? And so we go through, pixel by pixel. So for every y value, we'll define the line, and this is what we're actually going to print at the very end. And for every x value from 0 to the width, we shift around the left corner. So think of it this way: if we have the center of our screen to be 0, 0, 0, 0 in our particular case will actually be the left corner. We don't want that. We want to sort of move it to the middle, right? And that's essentially what this part of the code is doing, right? It's moving everything to the center, and dividing by the zoom value, right? And for the x value, we need to also multiply by the aspect ratio just to keep things not stretched and all that. Then we get the iterations. So in this case, we have the Mandelbrot set. So we have our Mandelbrot function. We see how many iterations it is, and then we bound it between 0 and 1, basically, by dividing it by the maximum iteration. After that, we are able to just floor the value and use the gradient itself to get the character, add the character, and there you go. So very quickly, before we continue, maybe we can just use the render function just to see if everything is working correctly. And very nicely, you can see that... sorry, I cleared it by mistake. You can see that everything is working. We have the Mandelbrot set, but we need to be able to move around and do, pan and whatnot. I wasn't familiar, honestly, with like using the terminal with TypeScript and all that. So I asked the AI to help me with it, and it created this code, which is fairly straightforward. This part, so yeah, we're using the read line. So let me actually import that in here at the very top. We're using the read line library, And in the case of a key press, if it's Control C, we exit. Left and right, we pan around and obviously divided by the zoom. And if we press X and Z, we will be able to zoom in and zoom out. And every time a key press happens, we will re-render everything. So console will clear the console and log everything again. Also on resize, because if we want to resize the terminal, same thing will happen. So now we have everything set, and we can actually run our code. And you can see in here we have a very nice, movable, explorable Mandelbrot set that is printed inside of our terminal. And obviously we can resize, move around. We can explore these sort of weird spirals that has. And you don't need to use this gradient. It's just one that I found online. There's a bunch of gradients that you can use, a lot simpler ones, etc. This one can be a bit noisy, but it is interesting to see how all these values are working together. So yeah, that's essentially what I have in here. And I guess I should also mention that I actually put this entire code that I have in as an npm package, and you can see also a GitHub repository. Everything will be in the description of this video. But if you don't want to clone it and all that, you can just basically write npx terminal-mandelbrot, and we'll sort of do that right now. And essentially, it will basically do that. I updated it yeah. So we have the entire thing in here, and you can just npx it if you don't want to actually check out the code. You just want to explore it on your terminal right away. You'll be able to do that. And yeah, that's what I have for this video. Basically, it's a very simple one. I didn't want to make a very complex thing. I just wanted to be able to explore the Mandelbrot in a fairly simple method without using shaders and doing all that stuff, and just on the terminal and straight away. That's why I even did the npx stuff. And yeah, that's essentially what I have for this video. Today is also Thanksgiving in Canada, so if you're Canadian, happy Thanksgiving. And yeah, I'll see you guys. I'll see you in the next video. Take care and bye-bye.